Just want to say thanks for everyone for coming and joining. We have a special one here today with our special guest from DataKin. I will introduce them in a little bit here, but we actually have some intro slides today, so that's a bit of an improvement over last time. So I just want to start with two things to start off here. The first one is about schedule. Ross, you want to jump slides? Yeah, so schedule-wise, this is going to be our last bi-weekly webinar of the year. We'll kick things up again on January 11th, so not 2 Tuesdays from now, but 3 Tuesdays from now, just to give everyone a break for the new year and the holidays. The second piece is our New Year's resolution. So this has been our first year doing these bi-weekly webinars, and I think they've gone really well. I'm really happy with the folks that come, the discussions, and so on and so forth. One of our resolutions for next year is we really want to get you all in the community more involved here. So if there are use cases that you want to talk about or partners you want to kind of hear about Airflow and the partner with or anything along those lines, please reach out to us and we will definitely make it a point to try and make them part of our schedule. The best thing about New Year's resolutions, right, is the best time to start is before the new year. So I like to say that we're actually starting a new resolution a little early with today's webinar with the folks from DataKin. So that said, I think we have the intro slide next for us, and we'll kick it to you to introduce yourselves.
Cool. Hello, everybody. I'm Ross Turk. I'm VP Community at DataKin, and I'll be here today to talk to you about the OpenLineage community. And I'm standing in for Julian, who is now traveling internationally for a family situation, and I have some pretty big shoes to fill, but I'm looking forward to talking to y'all.
Yeah, and hello everyone, I'm Willie. I'm the founding engineer of DataKin and also the co-creator of Marquez. So before that, before DataKin, I was at WeWork where I worked alongside Julie on the data platform team. Yeah, we co-created Marquez and incubated and eventually moved it to the LFAI and Data Foundation. Next slide. I don't know.
Yeah. Well, I guess we'll jump right in. So what we'd like to talk to you about today is first a little bit about data lineage, what lineage is, and how lineage metadata can help us run better pipelines and run better businesses. Dive into OpenLineage and Marquez. OpenLineage is an open standard for lineage collection, and Marquez is the system for lineage analysis. We'll spend a little bit of time talking about the differences between them. And then we have a little bit of a demo to show you about Airflow observability with OpenLineage. So that's our agenda for today. And starting off, I'd like to talk about the need. This is the why. Why lineage metadata matters, why it's important. And I'd like to start with just some basics about how to build good data inside of an organization. And it sort of starts with Maslow's hierarchy of needs, where we may all be familiar with this sort of pyramid of needs that sort of Maslow says starts at the bottom with food and water and then goes to a safe place to exist and then a loving environment and a positive self-image and then finally self-actualization. And I think broadly speaking, our lives are full of these like layered needs and capabilities. Like I very much want to give a great talk. So I made myself coffee, which means I needed to have hot water, which means I needed electricity, which means I needed fuel. And so we're kind of used to these layered things. And the same is true for data. Once you gain access to really interesting data, the next thing you want to know is, can I have this data updated in real time? And then you get addicted to having updated data all the time. And you start to wonder, is this the good stuff? Is this the data that I need it to be? Is this data quality good? So once you have data availability, then data freshness, you build upon top of that data quality. And then an organization that is consistently supplied with good data can begin to methodically optimize and improve things. Look for, anomalies in the data that can lead to action, that can lead to improvement and that sort of thing. So the reason that data lineage is important starts with this, that availability, freshness, and quality are the things that are required in order to build these sort of higher order, get these sort of higher order business benefits from data. But it's not super easy to build a healthy data ecosystem. Generally, they look fragmented like this. You'll have teams in different parts of the organization producing and consuming data sets, sharing them with each other, that sort of thing. And I think that once your org gets to a certain size, you end up with this kind of fragmentation. I think even in small businesses, this kind of fragmentation can occur. And it creates all these interesting opportunities for conflict and that sort of thing. But I think in general, this is a good thing. This is a really good thing, actually, because this is the result of successful democratization of the means of production. in this case, the means of producing data sets, I guess. But if you're able to make it so that people in your organization are empowered to produce and consume data sets and do advanced things with data, you end up with some fragmentation. So this is, I believe this is a very, very good thing, that sort of a healthy data ecosystem looks like a somewhat fragmented, chaotic mess in a properly functioning organization. Now, the bad part is that it turns data into this kind of black box. You can see the illustration on the left, very imaginative, it's a black box. It turns data into sort of a black box where you get this piece of data that is of extreme interest to you in a business context. You're looking, wow, I can make really smart decisions with this data, but what's the data source? What's the schema? Who is the owner of this data? When was this data created and how often is it updated? And where did it come from? What upstream jobs created this data? Who's using it? What happens if I give it to someone? Where does it go from there? And what has changed in this data? And so having sort of fragmentation of data and having it sort of spread organically through an organization is really, really good, but creates this challenge. And I think the solution to a lot of this is data lineage. So I'd like to define it. Data lineage is the set of complex relationships between data sets and jobs in a pipeline. That's it. Very simple idea. It's just a set of relationships between data sets and jobs. So for each data set, it's a list of the producers and consumers of that data set. For each job, it's a list of inputs and outputs for that job. And at the end of the day, it ends up being something very visual like this. It ends up being a map of your data pipeline that lets you understand how things affect other things. So that's data lineage. And now I'd like to talk a little bit about OpenLineage. There are a lot of different approaches to collecting data lineage, and OpenLineage is taking a very specific approach. But first, I'd like to start by saying that foremost, OpenLineage is a community. So there are all kinds of people who have an interest in data lineage. It's not something that just one vendor is interested in. It's something that I think we're all pretty much interested in. And I don't think that there's much to be gained by keeping this closed or keeping this under wraps, given that there are so many people in the industry and the ecosystem who can benefit. But there's a whole lot to be gained by having the whole industry work together to establish a standard for lineage so that we can all have sort of a lingua franca for talking about how data moves across all of these different tools. So first and foremost, OpenLineage is a community. And all of these folks were participating in the original specification, and we intend for OpenLineage to benefit everybody. So first and foremost, it's a community. And its purpose is to define an open standard for collection of lineage metadata from pipelines as they are running. Now, two things here are bolded. First is open standard. I just got done sort of talking about why I think that's important. I think it raises all the ships in the harbor if it's an open standard. That's the right way to go about this, I believe. The other thing that's bolded here is as they are running. Now, that's an interesting little phrase. OpenLineage collects metadata, or it collects metadata about lineage from pipelines as they are running. So why as they are running? What does that mean? To help explain, if we have any photographers in the room, we're familiar with Exif, which is the exchangeable image file format. And when you take a photo, your camera knows where it is, and it knows what time it is, and it encodes that information into the photo. You could get this information after the fact, I suppose. You could take a look at the image and try to recognize shapes and locations and time of day and time of year, and you might get scary close to the real answer. And it could be a whole lot of fun along the way, but the camera knows where it is. The camera knows what time it is. The best time to capture this information is when the photo is created. And the same thing is true for lineage data. The best moment to capture context about a data set is when that data set is created. So the way that OpenLineage works is it watches running jobs to determine data lineage. It captures data lineage as it's running, as opposed to attempting to reconstruct it after the fact from the information that's left behind. So the OpenLineage architecture was designed to do exactly this. All of the sort of producers at the top that produce data sets and do data transformations send lineage information through OpenLineage's collection standard to a variety of backends, which then allow it to give it to various consumers that require this data. It's a architecture for capturing real-time data lineage for operational use cases. And it's been designed to be extremely flexible to work with all kinds of different types of tools. And before a standard integration like this, you would have to, like the Marquez project would have had to build integrations with all the different analysis tools and schedules and warehouses and SQL engines, and other metadata servers like Ageria or Amundsen would have to do the same thing. With OpenLineage, we're able to unify a lot of this work so that these integrations, these data collectors can be built once, and they can benefit a whole cohort of tools that that need the same information. This is the purpose of OpenLineage, is to sort of standardize how information about lineage is captured across the ecosystem. And as you might expect, the data model for OpenLineage is accordingly very focused on the run state update, which is sort of a job run started at this time, it stopped at that time, and it will attach sort of information about the jobs and the data sets. So it's built around core entities of data sets, jobs, and runs. And when lineage is captured, it's captured as part of a run generally. It's defined as a JSON schema spec. And a really important key thing here is that there's consistent naming for jobs and data sets, so that different tools that deal with data differently can have a canonical name to use to refer to a particular data set or a particular job. I think for something like OpenLineage, which is an open standard, extensibility is everything. And so it's important to be able to sort of push the standard in various ways in order to accommodate all of the different use cases that people need. And the way that we do this with OpenLineage is through facets, which are atomic pieces of metadata that are sort of identified by a unique name and attached to an OpenLineage entity. So for example, if you have a bunch of great expectation assertion results that you want to attach to a data set, you can attach them using a facet, and it will sort of trace that information and version it throughout time. They're also decentralized, so you can use prefixes in facet names so that you can sort of define certain facets that can be grouped and promoted into the main spec at a future point. So the idea is that things that begin implementation as facets can then sort of become part of the main spec. An example of some facets might be for a data set, statistics, like I mentioned before, like a great expectations quality assertion, or maybe stats on row count or null count or things like that. Information about the schema could be stored in a facet. Version information or column level lineage could be stored using a facet. For a job, you might include the source code for a job, so that when you're studying the lineage metadata later, you can actually see the source code of the job. You would include perhaps some dependencies or a link to a version of the file in GitHub, for example, or maybe a query plan. And for a run, you might use a facet to store when it was scheduled or a batch that it was processed as part of, or perhaps a query profile or maybe some parameters. So facets can be used to extend each of these core entities in a variety of ways. And people often ask me, what is the use case for lineage? And it's one of these things that truly enhances every use case that it touches. When you're looking at a pipeline and you're trying to figure out something that went wrong, being able to trace dependencies and do root cause identification is really, really important. If you have, 10 DAGs that failed, you need to know which one to look at first. Having a lineage graph that shows how they relate can make it really easy to decide which one to prioritize. If you see that one is sort of related to all of the rest, for example. You can do things like impact mapping and planning. If I change this DAG, what is it going to affect downstream? These things are kind of hard to tell sometimes, especially if you cross systems from like Airflow to Spark, for example. Being able to do precision backfills, being able to say, for example, I know that this job, 5 jobs upstream changed at this particular time, and so I need to backfill all of its subsequent jobs from this time. So it allows you to sort of programmatically do backfills, etc. The possibilities, I think, are endless for data lineage. And now I think it's time to switch over to Willie, and he can talk to you about Marquez, which is the reference implementation of OpenLineage, and also is a system you can use for lineage analysis. So at this point, I will hand over to Willie.
Great, thanks, Ross.
Ross, that was awesome.
Yeah, great stuff. Yeah, thanks for going through that. So now, sorry, let me go to my slides. Great, so yeah, so Ross introduced us to the OpenLineage standard, which is now a very powerful way for systems to begin to admit lineage events and send them somewhere. So you could send it to Kafka. I mean, that's one example that we're working on, but you do need, in the end, something that processes those lineage events. And Marquez exposes a REST API that allows you to emit those events and capture those on the back end and process them. So the remaining part of the talk will be kind of going to the background of Marquez, the architecture, and also a demo on the integration that we've done with Airflow. Right, so at its core, Marquez is a metadata service. And if you look on the right, you'll see ETL, batch, and stream. So those are jobs or applications that we very much care about when we collect Lineage metadata, and they all post to REST API. And at the core, model, you'll see sources, datasets, and jobs. So as Ross mentioned, OpenLineage cares about runs. We care about datasets. We want to know where this data is located. So we want to catalog that. And then in terms of the features, there's data governance. So once you have metadata about your jobs and data sets, you can now introduce some governance around that. So Marquez allows you through a REST API call to tag data sets as having hosted PII, or maybe you could tag it as having sensitive information. And you could even do it at the column level. And this is important. So Marquez is not a data catalog per se, it's very lightweight, but you could leverage the REST API to say, hey, this job is trying to access maybe information about a user or users, and it shouldn't have access to that. So you could build on top of the APIs that Marquez has to then introduce some governance around what jobs should touch what data sets. And the way you could do that is through data lineage. So as lineage events are being emitted from batch and stream applications, Marquez begins to catalog that and build the lineage graph on the back end. And then Marquez also has a very simple search feature. So you can imagine you join a company and you want to know what are some top data sets, or what are some data sets that I should be using for my dashboard or pipeline that I was just asked to do, like how many, look at business metrics and stuff. So there is this option, which I'll demo, that allows you to search the data sets and jobs that have been cataloged. Now, if you look at the model of Marquez and you look at the model of OpenLineage, there's an intersection, right? So you see data sets, jobs, and runs at the core. That's super important. And then what Marquez introduces is the ability to version data sets and jobs. And what I mean by that is, as Marquez looks at the lineage events and looks at a job, it sees what metadata has changed. So a lot of the time with a job, the code changes, right? It's not static. So as your code changes, the integrations that we have collect the GitHub link or GitLab, depending on what you're using. And if that changes, we apply very simple logic to version that data set. And as you begin to collect or as you start a job, so let's say a Spark job starts, we begin to collect the run states, and that is then a run. And then we associate a run states to that run, and when it completes, it produces a dataset version. So you have this really nice dimensional relationship or multi-dimensional relationship that allows you to really debug issues when they come up, and data issues do come up often. And I'll go into sort of the next slide. But first, I wanted to touch about sources. So, when you're when you're collecting metadata around data sets, you want to know, where is it located? So is this a warehouse? Is this a stream? Is this an iceberg table? So we're working on adding support for a lot of those things, and a lot of them just kind of work out of the box. But what we're working on now is iceberg and a few other sources as well. So what are the benefits of this model? I think the biggest thing, that we ask ourselves as data engineers is, so, okay, when was this bug introduced? So usually someone or a data analyst, they give you some SQL, they say, okay, go ahead and put this or run this on a schedule, and usually use Airflow for that. And sometimes you have to tweak the SQL because sometimes it's not performant. So then you've productionized it, and you kind of get requests to make changes to that pipeline. And let's say you do that and you push it in production, and a lot of the time you don't know if something happens until a week later. Usually someone says, hey, this dashboard doesn't look right. Well, why is there a drop? Is this an anomaly? Is this a sort of an issue with the quality of data? So you'll be able to answer the question at what point in time was this issue introduced, and also what are the downstream systems or jobs that now are affected by that. So then you'd be able to do backfilling actually fairly easily, which is actually a tough problem to do right now. no one wants to do it, but they have to. And a lot of the time, you would have to figure out which data sets you have to backfill, right? So if you were able to identify the job that produced the error, because you have now that versioning component, you'll be able to do full and incremental processing of your data. So if you want to, what I mean by full processing is just like you want to do completely wipe the data set and reproduce it, or incremental, which means if you partition your data set by hour, by day, you can fill in those gaps or address the quality of those partitions if you have to repopulate them, and then trigger downstream jobs that now can use that corrected data. Okay, so Airflow observability with OpenLineage. So what I'm going to go into next is the integration that we have with Airflow, and talk about some of the metadata that we're collecting and how we're doing it, and then go into a demo. So yeah, the diagram on the left kind of just shows that you have the Airflow integration installed in your Airflow instance, and as DAGs run, we begin to use the integration to collect metadata around the task. So task lifecycle, that's very important because you want to know when your job starts, if it fails, and also when it completes. There's also task parameters, so those are going to be usually your run args, the parameters that you pass in, and those could be flags. So sometimes you provide a flag that says execute this code based off this condition. So you want to capture that, and that's really helpful for debugging later. And then the link to code, so component to it. So I'm assuming a lot of people are aware with you doing git syncs from GitHub to pull down your DAGs. And if you have that set up, the integration will actually grab the git SHA and build the link and send it to the Marquez backend. And we also then have SQL parsing. So we use this library that's open source that tokenizes the SQL that you execute. And then we don't care about all the SQL itself. We just care about what tables have been touched. And then we associate that with the run itself and mark those as inputs or mark those as outputs. And then by default, you then get inter-DAG dependency information. So as DAGs are running, they could be running on the same Airflow instance, which again, you could still go through and look at the DAGs and see the dependencies there, but it's still hard to do. But what a lot of companies do, and what we did at WeWork, we had 10 plus Airflow instances running per team or per org, and those DAGs depended on each other. So now you have this higher level view of all these different DAG instances, Airflow instances and the DAGs that are being executed, and the relationship is bubbled up one level. And the integration also has built-in SQL parsing, like I mentioned, that allows us to look at the input and output tables. It has the code builder, which is if you're using GitHub or GitLab, that's supported. And then this notion of metadata extractors, which I'll go into next slide. Oh, maybe not. I know it's coming, so sorry about that. But metadata extractors, they're essentially a one-to-one relationship. So for every operator, you have an extractor that looks at the surface level on what that operator is doing. So if it's Postgres, it's going to look at the connection ID and try to grab the schema for the table that you're touching, and then also parse you some SQL. But there's a diagram I have that I wanted to show you. But at a high level, sort of in a nutshell, what's happening is that your DAG is executing, and all this information is sent to the Marquez REST API, which then populates the model. So this is just a high-level diagram that I wanted to show you. It's a flow of information from left to right, and Marquez is able to look at that metadata and know how to version it and catalog it in the right tables. So the integration itself, we do. So if you're on Airflow 2+, we do support Lineage Backend. We do have an OpenLineage backend that begins to look at the DAGs that are running and the tasks. So there's still some improvement we need to do there, but this is the best way to get up and running with the integration, because you don't have to modify your DAGs. The older integration that we had required that you modified your import, and going forward, we want to leverage the backend feature that Airflow has. So you could do it through configuration, your airflow.conf file, or you could do it through an environment variable. Yeah, so this is the slide I was looking for. So as the operators are running, what we end up doing is looking at the DAG, and then for each task, or in this case, the operators that you use to define your task, we have this one-to-one mapping that looks at the operator, extracts metadata, and builds the OpenLineage event, and eventually makes the call to the Lineage endpoint. So really quickly, the steps that happen, and here we have an example for new room booking DAG that uses a Postgres operator, and all it's doing is just generating room bookings, just to sort of as an example. So the one thing that we look at first is the connection ID. So we define that as the source. So we begin to build the model that we saw in previous slides. So you have the source, and now you need to catalog the different tables that are associated with that source. So we tokenize the SQL. We look and see that, hey, we're inserting into a room bookings table. So that becomes your data set. And then the job itself is going to be the task ID. So there's a certain convention that we have to define the job. The job name, it's going to be the DAG ID plus the task ID. And that gives us enough uniqueness that's just a convention that we use. So it gives us a good way to convey where the task is coming from, or in this case, where the job came from. So, so this is a common example. So what I mentioned before, you have these two DAGs. You have one that's producing these new room bookings, and the other one that's now computing top room bookings. And normally you look at the DAG and it's like, okay, this looks great. But sometimes you have these dependencies that aren't really surfaced until you have a lineage graph. So when I say lineage graph for Marquez, there's data sets and jobs within the graph. So now this is surfaced, and you can see that there's two tasks that depend on each other. So one is just inserting, and the other one is doing a query and looking at the top room bookings for the day or week. Okay, so next I wanted to go into the demo. I have everything running. I'm sorry if I'm going through here. Okay. So what I wanted to show first is that locally, I have, that's not the one I wanted, sorry. Locally, I have Marquez running as well as Airflow. So there's the Marquez web container and also the REST API, in this case, the HTTP server. And I have the worker together, so I have Airflow running along with Postgres. So I need to do a little bit better at where are my stuff? Okay, here. So if we look at the Airflow UI, I just have two DAGs, and it's like a really simple example. I have counter and sum. So I have a DAG that is producing counters. If I go into the graph view, nothing really complex here. It's just checking to see if a table exists. And it creates a table if it doesn't, and then we're going to then increment a counter. So if we look at the code, we'll see that there's just two DAGs. I'm sorry, two tasks that we defined. Just the if not exists creates a table, and then the other one, the other operator is just going to randomize from 1 to 10 and insert those counts into a counts table. Right, and similarly, we do have a DAG that depends on that table. So here, what it's going to do is, again, create the table if it doesn't exist, just an initial step, and then also is going to do a total. So it's going to sum the table and sum the counts and then insert them into sums. Now for the Marquez UI, let's just do a quick refresh here. What I wanted to walk through is that we do see the tasks here. We actually see a few of them. So if I wanted to show really quick the search feature. So if you type in count, you'll see different results. So here what we end up doing is that there's the jobs that we get hits on, and also some data sets as well. So there's a counts table and the jobs. And what you can do is if you select on count int, you'll begin to see the lineage graph. And I wanted to walk really quickly through some things here. The one thing is the run history. So here we have a count inc job with the latest run, and below here, you'll see that these are all the facets. So the OpenLineage events that we collect, we also then define these facets. So facets are a way to extend the OpenLineage model, and all those facets are here and defined. So you'll be able to look through that through the UI. There's also the run history. So I've been running this just locally, so you can see, and you'll be able to click on a run and kind of look at the state at the time. And we can see that this job is searched into counts. So you can look at the SQL and see if anything has changed from run to run. And then the other thing is, we go upstream. We looked at that the count increment job has a output data set. In this case, it's going to be the counts table. So you can see it has one value field with the type, and if there was a description, that would be collected as well. And if we go back to the facets, for data sets and runs and jobs, the facets are different. So here we're collecting the schema facet for OpenLineage, and it shows you the fields as well as the data source. So we know where the source is coming from. And the one thing I want to point out is, when the DAG runs, we collect the schema at time of execution, so when the job runs. So you'll get up-to-date information on the metadata that is coming from that job, where if the schema changed, if the run state has changed, all that's in real time. And then you kind of go upstream and you go through the different job code that's here, and you can see what's being executed. And finally, the data set that we were writing our sums to. So the one thing I wanted to show as well is that the UI is a great component and really nice to kind of have if you don't have an existing data catalog. But some of our users actually just use the REST API. So if I do a curl, and I'm sorry, I can't see. I have to move this down a little bit. All right. So the one thing that you do see is that you're able to hit the the Lineage REST API that Marquez has. And if you define the node ID in the Lineage graph, so we have a certain format for that. We usually do, what is the job type? What is the node type? So you could have job or data set. Then you have the namespace, and depending on what type of node ID this is, it's either going to be the name of the data set or the name of the job itself, and it's delimited by a colon. So what I'm going to do is just make a call to the Marquez backend to get a lineage graph, and it should actually represent what we saw in the UI. And I'm going to pipe it to lineage.json. So if I just open that really quickly, what you begin to see is what the UI is using to display that. So at the top level, you have a graph, and the graph is going to be one or more nodes in the graph itself. So in this case, we have an ID for a data set, and there's additional information that Marquez adds to it, like when it was created, when it was updated, what are the fields, the source name, when it was last modified. But the important thing here is that you begin to see the in and out edges. So the node contains where possibly what job wrote to it, and also what are the jobs that are depending on this data set. And usually, I mean, if you're going to have a data set, the inputs, the in edges are going to be jobs, and the out edges are also going to be jobs. So this kind of builds, this shows you the power of the Lineage graph, it's the Lineage API, and something that you can use to start implementing your own tooling. So you don't need the UI, but if you wanted to just kind of use the REST API, you could do that. Let me see. I think that was much of them. You know what? I want to show something really quick. Yes, I'll just do it there. So I wanted to show the Lineage events that are being captured on the Marquez backend. Let's do a bash real quick. I did not type that correctly. Okay, great. So now on the backend, and you see jobs, runs, and so forth. All the events are stored in the Lineage events. So if you ever wanted to query that, you totally could. And Marquez keeps a log of all the Lineage events that are being captured. So what I'm going to do is just do a select on the event, the job name, and the table. And actually, event type, sorry.
I was going to say it's the first time I've seen someone use pSQL without a little Chrome tab on the side documenting.
Yeah.
Very impressed.
My fault. So yeah, so this is what I wanted to show you. I wanted to show you that as events are coming in, you'll see the start for the different jobs, the complete, and when. Yeah, so you'll see these two states transition, but there's also abort and failed as well. So that's what the power with OpenLineage. You can begin to build your own backend implementation. So if you want to start processing these events and you wanted to use Marquez as a reference, you could totally do that. But yeah, that's what I want to show there. So let me see if I can find my slides. Yeah, so that was the demo, and that's also all I had. So yeah, check us out. Here are the community links. We have monthly community meetings for both OpenLineage and Marquez. We have a Slack channel and a Twitter account. So check us out.
Awesome. Thank you so much for going through that.
Mhm.
Really good stuff. There's a bunch of questions here, and honestly, they're all OpenLineage related, not really Airflow related. So I can just feed them to you all. That's what the people want. So we give the people what they want. So one here, could you just go over again the relationship between the OpenLineage spec, the Marquez project, and the Datakin company? I think that would just make things clear for some of the attendees here. I will throw that to whichever one of you wants that.
I'll take it. OpenLineage is a spec. And so if you look at the OpenLineage project and what it contains the specification itself, which sort of talks about how you send lineage metadata to an OpenLineage backend. And it also contains the integrations. So the OpenLineage project contains the integration with Airflow, the integration with Spark, the integration with dbt and Great Expectations. That's what's inside the OpenLineage project. The Marquez project is the reference implementation of a lineage backend. So it implements the OpenLineage spec. Marquez is a thing you can run. You start its containers and it runs, and it's a long-running service, and you send it lineage metadata, and it has an API to study lineage, and it has a UI. So OpenLineage itself doesn't have a UI. It isn't a long-running service. It's just a specification and a set of collectors. And then Marquez is the thing you would deploy. And then Datakin is another Marquez that's built for additional use cases. So Marquez is the open source one, and it's really for sort of capturing and studying lineage, and Datakin is a product that takes it a bit further, going into operational use cases, looking for slow running jobs and duration and surfacing data quality and that sort of stuff. So Datakin is the SaaS product that is built on top of all of this, built for data engineers and Python operators. I don't know, Will, if you have anything to add to that.
No, that was great.
Yeah, that's awesome. I'm going to say that to make sure I understand it, but I'm going to say it in Airflowese just to make sure, in case anybody else, so what I heard is that you have, OpenLineage is an open specs. OpenLineage is almost like the DAG file, right? It's just a way to define dependencies and some amount of work. And then the scheduler is is kind of what Marquez is. It's an implementation of that spec. How do you actually schedule and kind of run that DAG? And then lastly, Datakin is like Astronomer to Airflow, right? Where it's a commercial product built around that. I love that way that you all did that, right? The open spec, I think, is just the most important thing, just because of how, Ross, like you were saying earlier, how diverse a lot of these data stacks are.
Yeah, well, it's interesting. I mean, Marquez started first, and OpenLineage evolved after. I think as the folks in the community realized that it could be a little bit broader. Now, that's definitely a Willie story, because he's the creator of Marquez, and he was there when all those decisions were made, and I was not. I came in a bit later, but it's one of these situations where we saw the need for OpenLineage because Marquez was starting to get traction, And we thought, wow, we could solve this for a lot more people than just the people who use Marquez.
Yeah, there's actually a question about that in the chat. So great segue. But in terms of what OpenLineage is, like, what if I want to use the OpenLineage spec to a tool like Amundsen or Atlas or any of the other kind of backends out there? Like, how would that work?
Yeah, that's a great question. Actually, Amundsen has OpenLineage support. It was a PR that they merged not too long ago. So that I think what they do is they send OpenLineage events to Atlas to build the lineage graph. So yeah, if you wanted to begin to capture OpenLineage events, first step is maybe possibly use one of the integrations that we have, like Spark and Airflow, and then that information would need to be sent to an API that they expose. And when those events make it to the backend, they have to be transformed in a way that can be inserted into Atlas or some other lineage graph as well. But again, so we're working on a way or a spec to tell the consumer of OpenLineage events maybe some guidelines on how to process. But currently, we've been focusing a lot on the producer side and what do we want to capture when a job executes. And the next step is now on the consumer side. Okay, what do you do with these events as they come in? But I know, reach out to those communities, open up an issue, tag one of us, and we'd be happy to drive the discussion there. But I know recently Amundsen has support for OpenLineage.
Awesome. Thanks for that thorough answer. I'm going to keep these coming along, right? Just to make sure that we can get to all of them. Cool. So what else does Datakin / Marquez and OpenLineage support? What is there a place where I can find a list of the connectors out there, or kind of the other systems they can integrate with?
So there's a good spot. If you go to openlineage.io and then you click on the integrations link at the very top, there's a table there that shows the different versions and platforms and links to all the different resources. I'm now looking at it and realizing that Great Expectations needs to be on here and isn't. So it is a constantly changing set because we're kind of we're in a growth phase right now. So all kinds of new integration work is happening. But Airflow, Spark, and DBT, Great Expectations is kind of the main ones now, I would say, where the support is most mature.
Awesome. And then a similar question is that SQL parser that you're using open source? And if so, which one is it?
It is open source. I think it's called SQL Parse. I would have to look at the OpenLineage repo to just see what we use. But we ended up building our own tokenizer analysis tool, which we always wanted to kind of maybe push open source. So if there's people interested in just using our way of analyzing SQL, we have to do that. And I could just take a really quick look to see what library we're using, but it's off the shelf. I think it's pretty popular.
Very cool.
I think another observation is that, like, for a Postgres backend, you need to do SQL parsing, but for a BigQuery backend, we can just ask BigQuery what tables it touched. So I think depending on the backend, I think SQL parsing is what we do when we can't get the explicit answer from the data store about what was changed.
That's a really good point. Yeah, BigQuery makes that so easy. We'll be sure to send out what that library is in the follow-up. So, well, you don't want to put you on the spot, but I'm putting you on the spot here again. Are you planning to implement column level lineage in Marquez, or is that already there?
No, good question. So that's been something that's been on our roadmap and a lot of people have been asking about. So column level lineage is on the roadmap, and we're working with Microsoft. So, Azure Purview has been involved in the OpenLineage community for the past few months. They started as a hack project, and the one thing that they need is column level lineage. So we're working with them on defining what that looks like. But it's coming, and it's going to be on our roadmap for next year. Because that's super important, because you want to know what tables depend on what columns, especially for PII and things like GDPR and stuff. You want to be able to track what are the derived data sets that have used a table that has PII in it. So that's something we're working on.
Awesome. Look forward to seeing that. Question from Manu in the chat. Are there cases where a dependency cannot be inferred because the task or query has dynamic bindings of the source or target table?
Yes. Well, for one, Python, if you're using a Python operator in Airflow, there's not much we can do. We're kind of seeing that now. A lot of organizations need to write custom code, and they usually use Python operators, and that becomes hard in terms of visualizing the lineage graph itself. And yeah, if you're using templating, when the DAG executes, we look at the task level when you're about to execute the SQL. So we're going to be able to parse it for you. So we're hooking it in pretty early. So you wouldn't have any issues there. But if you're using a Python operator or a Bash operator, we won't get much information unless you start writing some of those calls in the Python operator itself. But we're looking to provide some guidelines on maybe how you could define those operators differently.
Gotcha. Yeah, that answers a few of the questions in the chat here around.
Oh, okay.
Thank you for that fleshed out answer. Similarly, can you just go over again which versions of Airflow are supported with OpenLineage?
Yes. So 1.10 plus. And also 2.0 plus, right? So if you're on the latest Airflow grade, you can use the Lineage backend. And the good news is that we're working with the Airflow team to define a task listener, so we could better extract information from the task itself. Right now, if you're using the Lineage backend, we don't register failed jobs because the Lineage backend only knows about complete jobs. So there's a PR that's in progress that begins to collect both run and failed states. But if you're on an older version of Airflow, you would have to modify the import of your DAG, which we have docs on, and it's not too bad, but ideally you wouldn't want to modify your code.
Yeah, I've seen the docs on there. It really isn't too bad. It's a little, the first time you do it, it takes getting used to it. After that, it doesn't really affect the developer experience writing DAGs much, and that's the important thing.
Correct, yeah.
Yeah. Quick warning is there are still 26 questions in this chat here. I don't think we've gotten to, so I don't think we'll be able to get to all of them. So I think there's time for one or two more. Yarek, I think we just answered your question in the one below, so we'll mark that as done. Mukul is asking, I'm sorry, I hope I pronounced that right. Is there a way to plug in a Kafka consumer to the OpenLineage backend integration, or would that have to be plugged into Marquez?
Oh, that's a great question. So it doesn't have to be plugged into Marquez. The good news is that we're working on a transport layer. So when you use OpenLineage, you define a transport. So HTTP is one where it could send those events to Marquez. But we're also working on one for Kafka. The other thing that we're working on, and there's an open discussion in PR in OpenLineage, is a proxy backend. So you could then emit these OpenLineage events to a proxy backend that can route it to different streams, different systems. And we're working with Ageria, which is part of the LFAI and data, which is a standard for metadata storage. And the lead is from IBM, and we're working with them on the proxy backend, and something that they're contributing because they have the same sort of use case where they want to send these events to a stream. And then sort of fan out to other systems. And hopefully that answered the question.
Yeah, I think nail on the head.
Okay.
Thank you so much. You are very welcome. I'm going to mark that as done. And it's so tough to sort through all these on the Zoom Q&A. I'm doing my best here. I apologize. Cool. So last question from Robert here. And then if anybody has any more, please feel free to shoot them over to us in an email. Can you handle dynamic DAGs for data lineage the way things are set up right now?
I don't think we've tested that out. So I don't see why it wouldn't, just because if you're going to dynamically generate the DAG, in the end, once it executes, then the integration kind of kicks off because it depends a lot on the worker. So possibly, it'd be cool if someone tried it out, and if it didn't work, open up an issue in OpenLineage and let's solve the issue, and hopefully others can contribute that. contribute the fix.
Yeah, the beauty of open source there, right?
Yes, yeah.
Alrighty, so we're just about at time here. Thank you so much, everyone, for your questions. I really love the engagement here that everybody had. This is clearly a hot topic, so Ross and Lily, we're going to have you back at some point.
Yeah.
Maybe then we can show like what a production setup looks like.
Absolutely, yeah, I think that would be great.
Awesome. Alrighty, everyone. Like we said, the content will be sent over in an email to follow up, and the next webinar will take place January 11th. Where we have another special topic planned, but we'll leave that secret until the promotion goes. But until then, thank you all so much for attending these through the year, especially those that have been to more than one. And we're looking forward to kicking this into next gear, into the next gear in the next year. Wow, I'm a tongue twister here. Ross, Willie, thank you so much for your time. We really appreciate it.
No, thanks for having us.
Thanks. It's our pleasure.
All right.
Bye-bye.
Bye.